Welcome back to Python to AI, Episode 5. Look at this program. On the left, 12 lines of code to calculate the area of 3 rooms. Width times length 3 times over copy-paste. On the right, the same program in 5 lines. One function called room area. One loop. Done. By the end of the next 20 minutes, you will know how to write functions, the one trap that silently breaks every beginner's first function, and you will refactor last episode's guessing game into a clean 3-function version. Here is the path: why functions, the anatomy, parameters and return, defaults and star args, scope and the silent none trap, lambdas and the refactor build. Before the syntax, the motivation. Why functions at all? Here is the code from the cold open up close. On the left, 3 rooms, 3 copies of the same calculation. Width 1, length 1, multiply, print. Width 2, length 2, multiply, print. Width 3, length 3, multiply, print. It works. But look at what you just did. You wrote the same idea 3 times. If I ask for a 4th room, you copy-paste again. If I change the formula, say, area in square meters times a tax rate, you now have 3 places to edit. Miss one and your 4th room is silently wrong. On the right, you define the idea once. Def room area, parameters width and length, return width times length, 3 lines. Then a loop that hands each room's numbers to the function and prints the result. 3 rooms, 30 rooms, 300 rooms, the code is the same size. Here is the analogy I want you to remember for the next 20 minutes. A function is a recipe. You give it ingredients. Those are the parameters. It does its thing. A dish comes out. That is the return value. You do not rewrite the recipe every time you want to make the same dish. You follow the recipe again. Functions give you 3 things that matter. First, you stop repeating yourself. Programmers call that DRY. Don't repeat yourself. It has been a principle since 1999 from a book called The Pragmatic Programmer. Second, your code reads better. Room area open paren 4, 5 close paren is obvious. Width times length buried in a print is not. Third, changes happen in one place. Fix the recipe, every caller is fixed. That is why. Now the how. Every Python function is built from 6 parts. Name them once, you will see them everywhere. First, the keyword def, def short for define. This tells Python you are creating a function. Def is not a declaration. It is a statement that Python runs from top to bottom like any other line. That matters. You cannot call a function before the def that created it has run. Second, the function name. Pick something descriptive. Greet, count words, fetch user, snake case, underscores between words. Same naming rules as variables from episode 3. Third, parentheses with the parameters inside. Parameters are the inputs the function expects. This one takes a single parameter called name. 0 parameters is fine, 10 is fine. You are defining the slots the caller will fill. Fourth, the colon. Same colon you saw at the end of an if statement in episode 4. Python uses colons to say a block of code follows. Fifth, the body. Indented 4 spaces. Everything that runs when the function is called lives here. In this example, 1 line. MSG equals F quote hello comma space open curly name close curly exclamation quote. Sixth, the return statement. Return MSG. This is what the function hands back when it is done. Think of it as the dish coming out of the kitchen. Now the call. Over on the right. Result equals greet open paren quote ada quote close paren. Python looks up the function named greet, binds name to the string ada, runs the body, hits return, hands the string hello ada back. That return value lands in result. One thing to burn in. Defining the function does not run it. It is a recipe in a cookbook. Calling the function greet open paren is when you actually cook. Parameters and return. Inputs and outputs. The 2 ends of every function. On the left, parameters. A function can have 0 parameters. Def say hello open paren close paren colon. The function body still runs, it just does not need any input. Handy for things like printing a welcome banner. 1 parameter, def square open paren n close paren colon return n times n. Call it square of 4 gets 16. The caller passes 1 argument. The function binds it to n. The body runs, multiple parameters. Def add open paren a comma b close paren. Call add 4 5. Python matches positions. 4 goes to A, 5 goes to B. That is positional matching, and it is the default. You can also pass by keyword. Add open paren A equals 4 comma B equals 5 close paren. Same result, and now the order does not matter. Keyword wins over position. Use keywords when a function has several parameters and you want the call site to read like a sentence. On the right, return values. Return is how the function hands something back. Return n times 2. Return min open paren numbers close paren. Whatever the expression evaluates to becomes the value of the call. Here is a neat trick. You can return more than one value by returning a tuple, a comma-separated pair. Def min max, return min of numbers comma max of numbers. At the call site, you unpack into 2 variables on one line. LO comma HI equals min max of the list 3 comma 1 comma 7. LO is 1. HI is 7. 1 call, 2 values, 0 noise. Parameters in. Return out. That is the shape. Everything else is variations on those 2 ideas. 2 features that make functions dramatically more flexible. Default values and star args. Default values first. On the left, def greet open paren name comma greeting equals quote hello quote close paren. The greeting parameter has a default. If the caller does not supply it, Python uses hello. Call greet of quote Ada quote. You get quote hello comma Ada exclamation quote. Call greet of quote Ada quote comma quote hey quote. The second argument overrides the default, and you get quote hey comma Ada quote. Defaults are how you write a function that is simple for the common case and configurable for the rare one. Think of it as a menu. There is a default dish, but you can customize. One small rule. Default parameters must come after required ones in the parameter list. Def f open paren a comma b equals 3 close paren is fine. Def f open paren a equals 3 comma b close paren is a syntax error. Python reads left to right. One gotcha to flag and defer. Default values are evaluated once when the def runs, not on every call. That means if you use a list or a dict as a default, weird things happen across calls. We will cover that properly in episode 6. For now, stick to simple immutable defaults. Numbers, strings, true, false, none. Now star args. On the right, def total. Open paren star numbers, close paren, colon, return sum of numbers. That star is the magic. It tells Python collect however many positional arguments the caller passes and put them all in a tuple called numbers. Inside the function, numbers is a regular tuple. Total of 1, 2 gives you 3. Total of 1, 2, 3, 4 gives you 10. Total of just 10 gives you 10. Same function. 0, 2, 4, 100 arguments. It works. That is how print works. That is how a lot of library code works. Scope, which variables can see which. Python has a rule called legb, local enclosing global built-in. When you use a name, Python looks for it in that order. Local first, inside the current function, then enclosing any function that wrapped this one, then global, the top level of the file, then built-in, names like print and len that Python ships with. For now, 2 layers matter, local and global. Inside a function is local, outside is global. Look at the diagram. Name equals quote Python quote at the top level, that is global. Inside greet, msg equals quote hello quote, that is local. Greet can read name. Globals are visible from inside functions. But outside greet, print msg crashes because msg only exists while greet is running. It was born inside the function and it dies when the function ends. This is a feature, not a limitation. Your functions cannot accidentally step on each other's variables. Each one gets a private workspace. Now the trap. This is the one that breaks every beginner's first real function. Look at this code. Def clean open paren s close paren colon s dot strip dot lower. Looks fine, right? Cleans up the string, except no return, just the expression sitting there. At the call site, x equals clean of quote high quote. No error. Python happily assigns. But what is x? Not the clean string. X is none because every function in Python returns something. If you do not say what, Python returns none. None is a valid value, so the call site never complains. 6 lines later, print x dot upper. You crash, attribute error. Quote none type object has no attribute upper quote. and you will stare at the print line which is perfectly correct and wonder what happened. The fix is one word: return. Write it even when you think you do not need it. If your function is producing a value, hand it back. The trap is forgetting, not the concept. One more tool: lambda. A lambda is a one-line function without a name. Lambda x colon x times 2. Whatever is before the colon is the parameter. Whatever is after is the return value. Implicit, no keyword needed. On its own, a lambda is not useful. You can assign it to a name. Double equals lambda x colon x times 2, but Python's style guide actually tells you not to. If you need a named function, write def. Lambdas are for a very specific case. That case is this: Python's functions are first-class values. You can pass a function to another function, and some built-in functions take functions as arguments. Those are called higher-order functions. 3 to know. Map. Map lambda x colon x times 2 comma numbers. Applies the lambda to every item, returns a new iterator. Wrap it in list, get doubled values. Filter. Filter lambda x colon x modulo 2 double equals 0 comma numbers. Keeps only the items where the lambda returns true. You get the even ones. Sorted. Sorted words comma key equals lambda w colon len of w. Sorts by the value the lambda computes. Words get sorted by length instead of alphabetically. That is the lambda sweet spot. One line transforms handed to a higher order function. When the logic grows past one line, stop. Write a proper def. Lambdas are a shortcut, not a destination. Time to use every tool from this episode. Here is last episode's number guessing game. 15 lines of flat code. Works fine, but every idea is welded to every other idea. You cannot test the input logic without running the whole loop. You cannot swap the compare logic without editing the loop. Let us fix that. 3 functions. First, def get guess no parameters returns an integer. Inside, return in of input of quote your guess quote. That is the 2525 fix from episode 3 wrapped in its own name. One thing, one function. Second, def compare guess parameters guess and secret returns a string. Inside, if guess less than secret return quote low quote, if guess greater than secret return quote high quote, else return quote correct quote. 3 outcomes, 3 return values. Notice, every branch has a return, no silent none. Third, def play no parameters runs the round. Inside, secret equals random.randint 1 comma 100. Attempts equals 0, while true colon. And now the loop body is short and readable. Guess equals get guess. Attempts plus equals 1. Result equals compare guess of guess comma secret. If result is quote correct quote, print the winning message break. Else, print too low or too high based on result. Finally, if double underscore name double underscore double equals quote main quote colon, play open paren close paren. That last line is a Python convention. It means run play only when this file is executed directly, not when it is imported as a module. You will see it in every real Python script. Same game. 15 lines of flat code became 3 small functions plus a 4-line driver. Each function does one thing. Each function is independently testable. And if tomorrow I want to change how the player types the guess, voice input, keyboard, network, I change one function. The others do not care. That is the payoff. That is episode 5. Def, return, parameters, defaults, star args, scope, the silent none trap, lambda, and a refactor that turned 15 flat lines into 3 named functions. 5 episodes in, we have variables, types, control flow, and now functions. The Python foundations are almost done. Next episode, data structures, lists, tuples, dictionaries. The containers that hold the collections of data your functions operate on. Functions plus data structures is when the code you write starts to look like the code other people write. Subscribe and hit the bell. Drop a comment with the most useful function you have written so far. I read everyone. See you in episode 6.